Hello, my name is Belle Angitonasi, and today we're gonna talk about how the kidney tightly control the glomerular filtration rate (GFR), and then we will explain the acid-base balance of the body, and then we're going through the renin angiotensin aldosterone system, that one of the most important hormonal system in the body. So let's see, in your kidney filter about 180 liters of fluid a day, and the rate at which this filtration occur is called the glomerular filtration rate. Because the GFR affect the blood pressure, the glomerular filtration rate, and fluid balance and waste removal, the body must keep it stable. These are three major mechanisms that regulate the GFR. The first one is the renal autoregulation. The renal autoregulation is the internal kidney self-adjustment system. This part, you have two parts in this one. The first one is the myogenic mechanism. The myogenic mechanism and the renal auto regulation is when blood pressure increase, the afferent arterial stretch, like smooth muscle react by contracting, and which reduce blood flow into the glomerulus. These prevent the GFR from become too high. And then we have when blood pressure drop, the afferent arterial dilate, allowing blood in. These help the keep GFR stable. The second part of the renal autoregulation, the tubuloglomerular feedback. The tubuloglomerular feedback, the macula dense, this is located in the distal tubules, since the amount of the sodium chloride and the filtrate. If the GFR is too high and the sodium chloride level increase, the macula densa will signal that constrict the afferent arteriole. That means the GFR reduce. But if the GFR is too low, the sodium chloride level drops. The macula densa signal the afferent arterioles to dilate, so and stimulate the GF cells to release renins, so that in that case the GFR increase. The second major mechanism of the GFR is the sympathetic nervous system control. It is control from the during stress, shock, and heavy exercise. The sympathetic nerves constrict the afferent arterioles, like the blood flow to the kidney decrease. Like in that case, the GFR decrease to conserve water and maintain blood pressure for essential organs like heart and brain. The third major mechanism of the GFR is the hormonal control. The hormonal control contains the RAAS, the women angiotensin aldosterone system. It is a powerful hormonal contraction mechanism that raises blood pressure and increase GFR. Let's see step by step or the RAAS form. The women release by the juxtaglomerular cells when blood pressure drop, volume is low, and sympathetic nerves stimulated by the kidney. The sodium chloride delivered to the macula dense is low. And we have the formation of the angiotensin 2. The women convert the angiotensinogen to angiotensin 1. So the angiotensin convert enzyme then convert the angiotensin 1 to the angiotensin 2. And then we have the effect of angiotensin 2, that is constrict effect efferent arteriola, like this is increase GFR even when blood pressure is low. It stimulates aldosterone release from the adrenal cortex. Kidney retain sodium in water, increase blood volume. It is stimulating the ADH release, like increase water and reabsorption the collecting duct. It is stimulates thirst and the hypothalamus, like it is increased fluid intake. And then it is the vasoconstrictive of the systemic arterioles, like it's increased blood pressure. So overall of the effect, the red blood pressure increase the GFR and store blood volume. After seeing the three major mechanisms of the GFR, let's see how the kidney control pH. The kidney are essential for long-term acid-base balance. They do this mainly through the distal convoluted tubule and collecting duct. The kidney related pH in three ways. We have the first one is secretion of hydrogen ions, H plus. If blood become too acidic, the kidney secrete hydrogen ions into the filtrate. Those hydrogen ions are excreted in urine. This is where acidity is removed from the body. And the second one is the reabsorption of production of bicarbonate. The bicarbonate in the body's most important buffer. Like when blood is acidic, kidney reabsorb more bicarbonate into the blood, that they can also generate new bicarbonate. This is where we raise blood pressure in our body. And then we have the regulation of ammonions, excretions. Tubule cells convert like the glutamines into ammonia, which bind hydrogen to form the ammonions. The ammonions is excreted in urine. This remove extra hydrogen ions safely. For more, this acidic the acidic in the body, the more ammonium the kidney produce to excrete. In conclusion, the kidney regulate the GFR glomerular filtration rate through the autoregulator mechanism, sympathetic control in the RAAS system, the Renin angiotensins aldosterone system. The Renin angiotensin aldosterone system increase blood pressure, blood volume, and maintain GFR when pressure is low. The kidney regulate pH by secreting hydrogen ions, reabsorbing or making bicarbonate, and excreting ammoniums. The kidney and our body are incredibly efficient at maintaining homeostasis, ensuring proper blood pressure, fluid balance, and acid-base regulation. Thank you.